Okay. Yes, hello everyone and welcome to the live platform of IFAS. And today we are gathered here to study a very interesting topic of organic spectroscopy, which is called as mass spectrometry. This is going to be the first lecture on spectrometry chapter, mass spectrometry chapter, and this will be completely in English medium only. So I will be only speaking in English and I will be trying to convey the whole concepts in English medium only. This lecture series is specifically targeting those students who generally belongs to those states from a non-Hindi speaking state and they face lot of problem in understanding the concept. So we have decided that there should be at least one lecture for the students which is completely in English medium. So if you have some of your friends who face problem in Hindi as a language, you can share this lecture series to them also. And I hope this initiative by us will be helping you in clearing your exams, in getting the concepts of chemistry. Now, first of all, good morning to each one of you. Welcome to the live session. And this is the first time on YouTube I am going to teach you this mass spectrometry topic. Of course, this will be the lecture number 1 for this topic, and slowly, and this is a very small topic and we can cover this into a few lectures only, but I will try to cover this topic in a very holistic way so that if you are giving any exam related to organic chemistry and if mass spectrometry is asked there, then you will be able to attempt the questions of mass. I can guarantee you on this part. So first of all, good morning and welcome to the session. Good morning, Muskan. Good morning, Preet, BP, Usma, Komal, Anika, Sachin, to everyone. Very, very good morning. And let's start the class. If you have not yet liked the session, I would request you to please, in order to support me, if you want to support me, if you want that I should bring such type of lecture series more and more, then please do like the session. If you can share the session, it will be really very helpful for me. Okay. Good morning, everyone. So let's start your morning and let's make it a very, very nice good morning. Now, first of all, we will talk about the topics. Whenever you study any topic, you must to know what is the weightage of this topic in your exam or in any other exam you will be given. Be it any topic, you need to first of all see the such type of breakages. For example, talking about this mass spectrometry topic, question is asked in CSIR net exam also, GATE exam also, SET exam also, and there is one exam which is called as UPSC Geoscientist. In that, in the written part, that is in the mains portion, you get some questions from this topic. I will be trying to cover this mass spectrometry so thoroughly that you will be able to attempt the questions of this UPSC Geoscientist mains also. If someone is preparing for this exam, then this lecture series will be helpful for you. Talking about the CSIR net exam, for which we most of are here. So this year only in the July, which the paper which you have given or your seniors must have given, the question was asked on mass spectrometry. In I think it was asked in 2 marks. It was regarding the fragmentation pattern. You have to identify what was the m by z value of the fragment of the given molecule which they have mentioned in the question. Now, our aim will be to go through this chapter very thoroughly from the basics and to the advanced level. So, this fragmentation portion will be coming in a very later version of the classes, but it's very important to invest time on the basic portion also. Okay, so talking about the GATE exam, you may expect one question which can be of 2 marks, and the questions are very easy from this topic. You will see that you will be able to solve the question by just listening and making notes of this chapter. Again, if you are preparing for SET exam, 2 to 3 marks questions you may expect there also. And again, this topic we can see at least 1 or 2 questions are asked in each and every exam. in talking about the UPSC Geoscientist mains, there are three papers in the mains, and if I talk about paper 3, in that paper 3 you have a organic portion. In that organic portion, questions from mass spectrometry is asked, and it can be the topic, the number of questions, or I can say the marks which ranges from this topic can be from 20 to 25 marks. Okay, Sachin is saying, sir, इसके बाद में reaction mechanism करवा दो. Please, Sachin, now we are all in here in English, so the comments will also be in English. Please, वरना आप लोग मुझे distract कर रहे हैं. Okay, so please support me and try. I am trying my best to convey the lecture in English, and you should also comment and ask your doubts in English only. Okay, I am fine, Diksha. What about you? How are you? बिकॉज वेन आई, जब भी मैं यहाँ हिंदी का कुछ कमेंट देख लेता हूँ मेरे से रुका नहीं जाता और मेरी हिंदी निकल जाती है. तो प्लीज सपोर्ट मी एंड आस्क क्वेश्चंस इन इंग्लिश ओनली. गुड मॉर्निंग एवरीवन हु हैव जॉइंड लेट. गुड मॉर्निंग, वेलकम टू द क्लास. It's a request. If you can like the session, then if you like the content which I teach, then do like the session, do share the session. It really motivates me and supports me. Okay. Sir, is your name reaction session already covered? Not yet, Sandeep. We have not covered the whole portion. We have covered, I think, till aldol asymmetric reactions we have covered. And from, I think, Perkin or Reformsky reaction we have to start. But for now, today we are here with a very interesting topic of mass spectrometry. Okay. Okay. Yes, that's the spirit. I am good too. After a long time, I joined your class. Okay. Yes, I realize that after a very long time you are here. So carbene and radical chemistry, please. Yes, in the coming times I will be covering the carbene and radical portion also. Definitely I will be taking that. Sir, what topics will you cover on IFAS 26th batch? I will be taking the majority of the organic portions, but at the current portion current time I am busy with the previous batches, but the most of the major topics I will be taking. Okay, Ushma? Sir, I have watched all of you those. Thank you. Okay, I hope you must have enjoyed that. हिंदी बना सर के रग रग में. अरे यस, हिंदी तो भाई रग रग में बसी है, लेकिन this session is for those students who are belonging from a non-Hindi speaking states. So there was a huge request on our team side that, sir, please take a lecture in English. So here we are. Okay. Sir, I want to buy a test series. What should I do? Riddhi, if you want to buy the test series, you should contact to the IFAS team, or you can just visit the website, register there, and you should go to the learn free section and you can find the things, or you will find a phone number on a website where you can give a call and they will respond you positively. Okay. Okay. Now beginning the topic, I have already told you what are the things and how what is the weightage for this topic in different exams. Now talking about the different things you need for your CSIR net preparation, if you want to qualify LS in this coming exam, or you want to qualify GRF, then what you should do, you should know about the topic wise paper analysis portion, which we have provided you in the website in the detailed form, that if any topic is there, then what number of questions is being asked in part B and what number of questions are asked in part C, so that you can segregate and make a different strategy for part B and a part C portion. And I have given you a strategy also. I have made a video on YouTube which says that how to qualify GRF in first attempt. You may follow that strategy also. You will find that on the YouTube. If you want cutoff list, exam pattern, practice sets and demo questions, demo lectures, that all are available on the website. You may visit there. In the coming days, I am planning to upload some lectures. Sorry, not lectures. I'm planning to upload some questions from the reference books. For example, on the YouTube, I have covered name reactions portion for you people. So I have uploaded an assignment of name reaction here. You can visit the website. Actually, this is not currently on the website, but in the coming days, it will be uploaded in the website very soon. And we are planning here to upload the more questions of reference books. For example, I have made some questions from Zweiffel for the reagents chapter. I have given to the typing team, but they are still working on them. So in the coming days, we are hoping that these all questions are will be uploaded on the website, and I'm still working on the tests for intermediate, and these all questions will be from the Zoifil and the NARDS chapter and will be free for our YouTube students. So this is an initiative which I have decided to take, and it will be very helpful for you people. In the coming days, it will be available on the website. Keep checking the website. In today also it may come, or tomorrow also it may come, or day after tomorrow, but constantly the tests are being getting uploaded. Okay. For example, if you want to practice Claydon reaction mechanism questions, then also you will get these questions in the form of test and MCQ. You may enjoy this all. Now, coming back to the topic, let's come to mass spectrometry. Now, there is a very famous question on mass spectrometry which may be asked to you in any interview also. In rest of the spectroscopy topic, we are always calling them as spectroscopy. I always use a word spectroscopy, but here we are using a word which is called as spectrometry. Can anyone tell me in the comments what is a difference between a spectroscopy and what is a difference in a spectrometry? And is there anyone in the comment section who have worked on this mass spectrometry instrument? Is there anyone? Have you ever drawn a graph for, let's suppose, any organic molecule and found the fragments? Have you worked on this? Electromagnetic radiation not used. Okay, very good. Sir, net GRF LS, which is the, okay, just wait just a minute second. Sir, net just LS और कट ऑफ डिफरेंसेस कितना होता है ये भी थोड़ा बता दो. First of all the comments should be in English only. Please do support me. I am taking the lecture in English, and I am seeing that there are a lot of people who have not yet liked the session. So it's a request. Please like the session. So it will be a gap of near about 10 to 8 marks in the cutoff of GRF and LS. Okay, Aisha? Sir, I want to know, take only organic batches from the IFAS platform. Yes, it is available. You can contact to our team Pulkit. Okay. Yes. So in a mass spectrometer, we never use any electromagnetic radiations in order to draw the graph. That's why this mass technique, yeah, mass analyzing technique is never called as mass spectroscopy. Rather than we always call them as mass spectrometry. What's the reason? See, if I talk about, let's suppose, NMR, you must have studied about nuclear magnetic resonance, that is NMR spectroscopy. Can you tell me in the comments which type of electromagnetic radiation is actually used in NMR? Yes, you have a whole electromagnetic spectrum, and in that you have a various electromagnetic radiations in different wavelength regions. So which radiation we actually use for a NMR? Then the answer is radio waves. You people are very much correct. The waves, we can say the electromagnetic radiations which have least energy is the radio wave, and that is used for studying NMR. In NMR, what happens? We do nuclear spin transitions. If you remember the chapter which I have taken on NMR, it is still available on YouTube. If you have not covered yet, I will suggest you please go and visit the lecture series for NMR. It's very interesting. I have covered in a very new way. Now, it is called as nuclear. Now, using the radio waves, what we do is we do nuclear spin transitions, and then only we get some transitions and for which graphs are plotted. Now, there is one more spectroscopy which you study is called as IR spectroscopy. I should not ask, but I will. Which type of radiation is used in IR spectroscopy? Tell me. And tell me what happens at the molecular level in the bonds which are present in an organic molecule. If I irradiate any organic molecule with a IR radiation, then what is happening in the bonds when this IR radiations falls on an organic molecule? Can you tell me? Yes, this is very much correct, sir, that IR radiations are used in IR spectroscopy. This anyone can tell us. Of course, it's a very easy question. But what happens to the bond? they actually start to vibrate. Yes, that's why you people also study vibrational spectroscopy in physical chemistry chapters. Right? Yes, sir. Moving ahead, let's suppose you were studying UV spectroscopy. Again, I should not ask, but I will. Which type of radiations do you study when you are dealing with UV spectroscopy technique? And also tell me what are the types of transitions were taking place. For example, in IR, what you do is the transitions take place between the vibrational energy levels. In NMR, the transitions take place between the nuclear spin levels. In UV, which type of transitions do you study? Yes, very correct. Sir, in UV, we use UV radiations. Yes, sir, very easy. UV radiations. But if you are asking about the transitions, then always remember electronic transitions takes place. It means the electrons which are present in any molecule actually undergo transition. If you have heard about, let's suppose, Laporte selection rules, you must have heard about spin selection rules. They all are actually applicable in this electronic transitions only, where you are using UV radiations. Can you tell me in which chapter have you studied about these things? About Laporte selection rule, about spin selection rule, Laporte partly allowed things. You study these all things in coordination chemistry when you study about colors of the inorganic complexes, colors of the elements which are present in the D block elements, colors about the F block elements. There you study about electronic transitions, and the radiations which you are using are actually UV radiations. That one portion is covered in the inorganic portion, and one more portion of this UV radiation is covered in the organic portion, which we will see on YouTube if time comes. But number of questions which is asked from UV is quite low. That's why we can skip this portion. But this mass spectrometry topic is very important. Now, since I have explained you these three terms, what happens in the organic molecule, can you tell me when I put a organic molecule in a mass spectrometer, then what is the actual thing that is happening to a organic molecule? Who can tell me? Please at least try in the comment section. What will happen to the organic molecule when it is placed in a mass spectrometer? At least try. And I'm really sorry, my English is not that well, but I'm trying my best. Really. Yes. Yes, Akash is saying that ejection of electron and generation of a molecule ion. Very good, Akash. You are on a very right path. And I am seeing that the number of people who are watching us live and the number of likes on the session are not equal. It is very unjust and unfair to me. Please like the session. An organic molecule fragments. Yes, very good. Excellent. Molecular ion generates. You must have seen a symbol written as like radical cation, right? On an organic molecule. What does this happen, sir? And how this has happened? See, I will not be just covering the question portions of the mass spectrometry. I will be covering in a very holistic way what happens in a mass spectrometer. That also we will be studying here. Okay. So the correct answer is yes. Sir, whenever an organic molecule is placed in a mass spectrometer, actually molecular ions are formed, and sometimes or most of the times the organic molecule fragments, and we get a smaller fragments which actually reaches to the detector and the graph is plotted. Got it? But how this actually works, let us study in a little more detailed fashion. Now, moving ahead from here, now you need to promise one thing to me, that you will be preparing notes of this chapter very thoroughly from the first lecture till the end of the lecture. And you will be taking this lecture series very seriously, because you will be able to solve each and every previous year question of your CSIR NET exam, GATE exam, SET exam, if you make the notes properly and you follow the things which I told you here. I will be telling you here. Okay. Clayton says that it's like hitting two bricks and one part fragment. Yes, Bill. Uh, देख रहे हो हिंदी निकल जा रही है. Yes, very rightly said Sandeep. Sir, complete topic coverage करेंगे ना sir. नहीं Shine. First of all, comment in English. Otherwise, your comments will not be read. Yes, I will be covering this whole topic. I promise that I will finish mass spectrometer on YouTube. Now, coming ahead, so this we have already discussed that in a mass spectrometry, the electromagnetic radiations are never used. Here, the analysis is done on the basis of fragmentation patterns. That is, an organic molecule actually fragments in a smaller fragments, which reaches to the detector, and that is detected by the detector, and the graph is plotted. Plus, we will also see that there are some isotopic peaks concept which very often, from where the very often questions comes into our exam also. Okay. Now, first of all, I would like to show you a figure. And are you familiar with this figure? Have you seen such type of figure anywhere? This actually is a ionization chamber. Now, should I draw this in your now the question which must be coming in your mind, should I draw this in my notes, sir? You can draw. If I would be in your place, I would have drawn this, because some the concept which you are learning now may be useful to you anywhere, anytime. So who knows, it may be asked in an interview also. So please make notes your notes very thoroughly. Okay. Now, the thing which you are here, the thing which you are looking here is called as an ionization chamber. What happens to an organic molecule when it enters into this ionization chamber, and how this ionization chamber works, we will be covering each and everything in a very detailed fashion. You must be getting a feeling that sir, it is a kind of water bottle with a neck at this center and with a backside at the opposite center. Yes, this is what it is looking like, that it is a horizontal bottle, right? Yes. Sir, it's a mass spectrometer. No, it's a very small part of a mass spectrometer. It's just the ionization chamber. There are other parts of the mass spectrometer also, which we will be getting after the mass spectrometer plus before the mass spectrometer. When you will be studying analytical chemistry as a topic, or you will be preparing for UPSC Geoscientist mains, there you will study lots of other components of this mass spectrometer also. But for now, we have just picked the ionization chamber of a mass spectrometer. The book which I am referring is Pavia, and I will be just telling you the whole concepts which are written in the Pavia in a very concised manner. Okay, see what happens. The line which you are seeing here, which is going like this, I am highlighting the line. This line is actually representing that your organic molecule is actually traveling this way. Let's suppose what happens, we have a organic sample and we have vaporized our sample and converted that into a gaseous phase. And when that sample enters into the ionization chamber, it is entering from the backside this way. Now, inside this ionization chamber, we have some filaments. If you can see the filaments here, I hope this picture is clearly visible to you. These are the filaments. One filament is present here and the another part is present here. This is called as anode. The positive terminal is called as the anode and the negative terminal will be called as then cathode. Now from these filaments actually very highly energetic electrons are traveling, and these electrons are traveling from a negative side of a terminal to a positive side of the terminal, and these electrons are very highly energetic, and when this stream of organic molecule passes through this electron beam, there is a bombardment. What you are trying to say is, what I am trying to say is that let's suppose this pen is the organic molecule. Let's just suppose that, and this is traveling, 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 and from here highly energetic electrons are coming, which will collide or which will strike this organic molecule, and there will be a electron bombardment on this organic molecule. What does a bombardment means? Lots of electrons will be striking this organic molecule. This is what happening inside the ionization chamber. Now, some of the organic molecule may lose an electron because of these striking. For example, let me give you a better understanding. Let's suppose in any organic molecule you have a CH bond. Okay, in this sigma bond, how many electrons are present? You will be saying that sir, 2 electrons are present here. Now let's suppose an electron, a highly energetic electron strikes this organic molecule, and it ejects one of the electron from here. One of the electron is ejected. Then what happens is only a single electron will be present here, and one electron will be ejected out. For that ejected electron, we use a positive sign, and since we have only a radical system now left, for that I will be using a single electron, representing a single electron, a single radical. So, did you get the meaning of this, which is called as radical cation? This type of system, or this type of positive and a single electron, is called as radical cation. Now, how it is formed in a mass spectrometer? Because in each and every molecule which you will be studying in a mass spectrometer, you will be converting that into a radical cation. Now, let's suppose this was an organic molecule which has 2 electrons in its sigma bond. Electron bombardment takes place, one electron strikes off, and what is left now is a radical, single radical, and a positive charge for the electron which has gone. So, now this radical cation, after the electron bombardment, this radical cation was moving, and again an electron strikes, and this time this molecule fragments into 2 smaller fragments, and these fragments start to travel in the stream. फिर से one more time. See what was happening. This organic molecule was traveling, electron bombardment take place, this become a radical cation. Another electron strikes, this is converted into 2 fragments, and now these 2 fragments are traveling in the stream. This is what happening inside a ionization chamber. Now the 2 smaller fragments will be traveling over this path. Now, so what is the use of these plates, sir? You can see a circular disc-like plates. What are they? They are actually accelerating plates. See, these accelerating plates are kept at a negative terminal, or you can say they are having a negative sign, negatively charged, and the radical cation is positively charged. So they will be traveling inside these plates without getting deviated from their original path. Did you get this? So they are helping these fragments, or you can say the fragments which are present in the stream, to travel in a linear path. And this is called as focusing slit, through which this stream is passing. And finally, we call this stream as an ion beam, because in this stream we have radical cations, we have ions. So it is now called as a ion beam, which was earlier a sample system, or you can say a sample to be analyzed stream was entered into the bottle, and what is coming out is a ion beam. Are you able to get the concept which I just told you, I just explained you? Are you are you able to make a picture inside your mind how the organic molecule enters an ionization chamber, how the electron bombardment is taking place, what is a radical cation, how they are traveling inside the chamber? And now what will happen? I will be explaining that. But first of all, give me a confirmation, yes sir, that we are able to understand and make a picture inside our mind that what is actually going inside a ionization chamber. Sir, please use some Hindi sometimes. No Ganesh, it's my prad today that I will be teaching in only in English. I'm trying my best, and don't demotivate me. Yes, sir. Got it. Got it. Got it. Everything okay. So only C positive is coming out. No, it's not C positive. It's a radical cation. Don't use a carbocation word here. What is it? Is it? It is a radical cation. Okay. Now see what happens. Moving ahead, now we have these ion beams. Now these ion beams are sent to a magnetic field. What happens in this magnetic field? Depending upon the mass by charge ratio of a fragment, these fragments are segregated in the magnetic field. I know you didn't get anything. Now, let me take an example, then only you will be able to understand. Let's suppose I am having a molecule as C5H11. This was the original organic molecule which was to be analyzed in a mass spectrometer. Now, the stream of this organic molecule was allowed to enter into the ionization chamber. What happens is, sir, a electron bombardment take place. I am writing this here, okay? It will be easier for me to represent. Now, on this, what happens? Electron bombardment takes place. After the electron bombardment, this is actually converted to a radical cation. Now, for this radical cation, what I can do is I can calculate M by Z ratio. What is this M by Z ratio, sir? See, for any radical cation, we always calculate this M by Z ratio. Here, M represents the molecular mass. This should be C5H12, or we can take C5H. Let's take C5H12, no, not 11. Now, M represents the molecular mass. So when I will be calculating the molecular mass, I will be saying that 5 into 12. 12 पंजे, oh नहीं 12 पंजे नहीं कर सकते. 12 5s are 60 and 60 plus 12 comes out to be 72. So the mass comes out to be 72. And now the charge, Z here represents the charge on the organic molecule. What's the charge? So a single positive charge is present here. So I will be calling it as +1. So the M by Z ratio is actually equal to 72, which will be always equal to the molecular mass of the fragment. The M by Z ratio for any fragment will be always equal to, I will be saying that it will be always equal to the molecular mass of the fragment. Now, see what happens if an organic molecule which has been converted into a radical cation now is traveling. Now, there will be certain portions in this organic molecule which wants to break, because that bond is a weak bond, or either we can say if a bond break, then a very good fragment, for example, water molecule or a neutral molecule get eliminated. So, from a very weaker section of this molecule or center from where a weak bond is present, this molecule can break into two fragments when another electron strike this radical cation. Then we can say that, sir, this fragment has been converted into two smaller fragments. One is, let's suppose, C3. Again, I have written this as 11. Pardon me. This will be 12. Now, let's suppose I have C3 and then I have, let's suppose, number of hydrogens which I am taking is 6 8, C3H8. Now what is left is C2 and H4. So again I will be getting a M by Z for this also. I will be getting a M by Z for this also. Tell me what will be the M by Z for the first fragment. So again you need to calculate the mass, sir. 12 3s is 36 and 36 plus 8 gives us how much? 44. So the first fragment will be at the 44, and for the C12, sorry, C2H4, we can say that 12 2 ja 24, 24 plus 4 comes out to be 28. So the second fragment will appear as a at 28. Always remember, when you add the M by Z values of the two fragments, it should be equal to the M by Z value of the original fragment. If I am adding 44 and 28, does it coming equal to 72? So sir 40 8 आदत से मजबूर 8 4 12 4 2 6 and 7. Yes, it's correct. it means we are going right. Now these smaller fragments are going to travel and they will be present in this ion beam. Got it? If you have got the concept of m by z, then you will be able to understand how the deflection takes place in the magnetic field. See, let's suppose I have two different fragments. One is of a very lighter weight and one is of a very heavier weight. Or you can say, let's suppose I have two persons. One is a very thin person. He is approximately of 30 kg, and one I have a very fat and a big person who is actually of, let's suppose, 100 kg. And they are placed in a very high speed moving wind. Now, tell me, the deflection will be more for the man which is of who is of 30 kg or for the man who is of 100 kg? Tell me, which person or which man will be deflected the most in a very high speed moving wind? Similar situation is present here also. सर आप इंग्लिश में पढ़ा रहे हो तो आपने वाह वो वाले हितेश सर नहीं लग रहे हो. आई एम दैट हितेश सर ओनली. लेकिन अब क्या करें यार, अब इंग्लिश है तो इंग्लिश है, अब वो टोन थोड़ी निकल के आएगा इंग्लिश में, नहीं. बट यू हैव टू मैनेज विद दिस. दिस इज अ समथिंग न्यू which I am also trying and you should also enjoy this. Okay. लपेटे में ले लेंगे. यस, अब लपेटे में ले लेंगे को इंग्लिश में क्या कहेंगे यार? क्या बोलूं मैं लपेटे में ले लेंगे को? अच्छा नहीं लगेगा ना कि लपेटे. व्हाट विल बी द इंग्लिश फॉर लपेटे? आई विल बी रोलिंग दीज थिंग्स. देखा. आई एम फ्रॉम साउथ helping. Okay, I hope the persons who face problem in Hindi now will be able to get the concept very easily. Okay. Takes account. I think we will rock it. Yes. सर अपना रिएक्शन मैकेनिज्म अधूरा है. यस, अधूरा है, करेंगे पूरा. ओके. टेक द लपेटे. ठीक है, चलिए मूविंग अहेड. व्हाट आई वाज टेलिंग यू, भुलवा दिया. यस, we were having two men, one of 30 kg and one was of 100 kg. Who is going to face the deflection more? Of course the 30 kg man will be उड़ जाएगा यार वो. He will be gone. It means a lighter fragment of we can say a lighter fragment or a fragment with a very less m by z value will be deflected the most, sir. So can you tell me what will be the which fragment will be deflected here more? If let's suppose this is the first fragment and this is the second fragment, then of course the fragment with a m by z value of 28 will be deflected more in the magnetic field, and then finally it will be reaching to the detector. Now, what detector does here? Detector actually counts the number of fragments which he is receiving for, let's suppose, m by z 28, and he will also count the number of fragments he is receiving for 44, and then corresponding to the number of counts which he has received, the detector will be giving us a very nice plot which you call is as a mass spectrometer graph. That also we will be covering in the coming time, but for now, is the concept of ionization chamber crystal clear to everyone? Then I can move ahead. सर पूरा सेशन इंग्लिश में होगा क्या? ओह माय गॉड रूपा, आप लेट आए हैं क्या? सिर्फ इंग्लिश में नहीं होगा. Now you have to also comment in English because these lectures are in English medium and these are for the students who are from South and they face Hindi as a barrier in understanding chemistry concepts. Okay, this we have started a new initiative. I also need support from you, and the people who have joined late and not get like the session, first of all like the session and comment in English. सर समझ नहीं आ रहा, अब ये मत बोलिए भाई गणेश, ठीक है? ऐसा तो नहीं है कि नॉर्थ के बच्चों को इंग्लिश समझ नहीं आती है। अब जिनको हिंदी नहीं आती उनको तो बिल्कुल ही नहीं आएगी ना यार, उनके लिए तो हम इंग्लिश में कर रहे हैं। ये मॉर्निंग का सेशन होगा, अगर 5 बजे सेशन होगा तो वो कंप्लीटली वही देसी हिंदी होगी, उसकी टेंशन मत लीजिएगा। लेकिन अगर मैं मॉर्निंग में कोई सेशन लूंगा तो दैट विल बी इन इंग्लिश, ठीक है? सर ने रिमेनिंग नेम रिएक्शन सेशन कंप्लीट करेंगे क्या? करेंगे सचिन, बिल्कुल करेंगे। आप लोग का रिस्पॉन्स अगर बना रहता है तो मैं जरूर सेशन करता हूं यार। सर टुमारो ऑनवर्ड्स हिंदी प्लीज, नो हिंदी हियर इन 11 AM लेक्चर। सर समझ आ रहा है दोनों में, वेरी गुड, दैट्स व्हाट आई नीड। ये कहाँ आ गए सर हम इंग्लिश की दुनिया में, ऐसा लग रहा है हम फिर से गुलाम बन गए। अरे नहीं भाई, गुलामी उलामी की कहाँ पहुंच गए आप लोग? वी अंडरस्टैंड ऑल हिंदी, वेरी गुड। अच्छा बंगाली भी, वो तो नहीं आती सर। आई एम कंफर्टेबल विद इंग्लिश टू, वेरी गुड। सर देन टेक सेशंस एट 5 PM। अरे बाप रे यार, थोड़ी तो मैनेज करो, थोड़ी तो इंग्लिश मैनेज करो, ऐसे कैसे चलेगा? Sir, I want to, Sai, if you may call to the given number which will be available on the website. If not, you can contact me on the Telegram. You may join the IFAS Chemistry Telegram channel. There also you will get some contacts. You may connect to the team there also. Okay? Or you may visit the website. Sir, we want Hindi sessions. Hindi session शाम को 5 बजे, अभी नहीं। चलिए, moving ahead. Should I move ahead? Sir, please complete the remaining name reaction portion. Yes, Kamini, I will complete. I'm planning to complete that, but that session was holded because the response of people were not good and I was not feeling good to teach so few people. So I just kept that topic on a behold. But next time I will be continuing the name reaction portion. Don't worry. Now, coming ahead from here, this I have told you already. What we can, yes, there is one more component after the mass ionization chamber, and that is a quadrupolar mass analyzer. This we have not to study here. We will be not covering this quadrupole mass analyzer. But if any student is preparing for UPSC Geoscientist mains exam, this is present in your syllabus. You need to study what is the functioning of a quadrupole mass analyzer. For the students who are preparing for CSIR NET GATE set, only the concept of ionization chamber was necessary so that you can make a picture how actually a spectrometer works. But if I talk to tell you a little bit what is happening here, this is your ionization chamber which we have just studied. Now this is the ion beam which is actually reaching to the detector. In the way, we have 4 electrodes arranged in such a fashion which are parallel to the ion beam, which under which the molecule ions are traveling. Now, there is a whole different concept for this quadrupole mass analyzer. I am not going there, but the students of UPSC Geoscientist mains will cover that, and you may read Pavia book for this topic if you want to do so. Now, moving ahead, how the detection mechanism is working here, this we are going to find here. Let's suppose I was having a C5H12 molecule. Now, this C5H12 molecule undergoes an electron bombardment, and what we have converted this into a radical cation. Now, this radical cation may get converted into many smaller fragments. For example, we can get C3H8 as a fragment, and then C2H4 as a fragment. Again, these will be also a radical cation. And let's suppose one of the fragment is C4H10. Then the other fragment will be C1, and I can say C1 will be not allowed. What should I take? Let's suppose I have C4. Then in such a situation, what is left is C2, no? Or I may also increase the number of carbon. Let me increase the number of carbons. Let's suppose we have C7H 16. Now the fragments will change here. If I am taking C3H8, then the fragment which will be left here would be 4, because 4 plus 3 makes 7, and this will be your 8, because 8 and 8 makes 16. So this is the fragment 1 and this will be the fragment 2, which have been originated from the original radical cation. Now talking about this, if this is C4H10, then this fragment will be C3. Or let's suppose I am taking a little different one. This is C5H10. Then the fragment which will be present here will be C2H6. I am just creating a hypothetical example so that I am able to explain you the concept. Now we have these 4 different radical cations. Now according to their m by z value, they face a deflection in the presence of magnetic field. Now let's suppose I am giving you a question on deflection. If you have O2 2 positive, you have O2 positive, and you have, let's suppose, O2. Okay, and the isotope which you have here is a 18 isotope, you have here a 16 isotope and a 16 isotope. Can you tell me the deflection order for these 3 radical cations, or you can say these 3 fragments? What will be the deflection order? Which component will be deflected the most and which will be deflected the least? This is what you need to tell. Let's suppose this also has a +2 charge. The question which I'm asking you is, tell me the deflection order. Which component will be deflected the most and which component will be deflected the least? A, B, C. Arrange them into the deflection order. Yes, do answer. Yes, very good. The mass will be actually inversely proportional to deflection. The concept of deflection says that it is inversely proportional to m by z value. If the m by z value is very high, then the deflection is going to be very low. Talking about the, first of all, we need to calculate the m by z value, sir. And how it will be calculated? For this O2, which has a mass number of 18, we will say that 18 twos are 36, and divided by +2, because it has a charge of +2, it is going to come as 18. For this, it is going to come as 32 and +1, so it will be equal to +32. Very good. Excellent. And for the last one, what we have is 16 दूनी 32. So you have 32 divided by 2. This gives us +16. So the deflection order will be, the highest deflection which the fragment is facing is the C1, and then the A1, and then the B1. The B ion being the heaviest will be facing the deflection least. This will be the order of deflection. Now, sometimes the question may be asked on the deflection order also, so you must know it is always inversely proportional to the m by z value. Now, from here next, what we are going to say is how a graph of mass spectrometer looks like, what is a molecular ion peak, what is a base peak, and what is a isotopic peak. But all these things we will be covering in the next lecture that I will be taking tomorrow. The timings are going to remain same at 11 a.m. and I hope the response which you have given today to me, you will continue tomorrow also. And this is a very interesting topic. We will learn this topic thoroughly. Okay. Now, talking about if someone wants to know about the test and the questions, or about you want to learn new things about CSIR net exam, let's suppose you want to have a look of previous year questions for CSIR net exam. This is available on the website. if you want topic wise analysis, because this is very important, if you want to see whether the mass spectrometer questions are coming in part B or part C, in which year the questions has come on part B and which year in part C, such type of analysis is available on the website from year 2011 to 2024. You may also use them. Year-wise cutoff list, what is the exam pattern, syllabus, important dates about the exams, these all are available on our website. You may visit there also. In coming days, what I am planning to upload few questions which I have already told in the starting of the session, and this I have given to the typing team. They are working on that. Some assignments of reagents from the Zweiffel, and these are freely available to the YouTube students who constantly are connected with me. I have taken an initiative to give you reference book questions in a form of MCQ freely on the website. You may also take advantage of this. Always remember the number of uh, total number of marks which is asked in CSIR net exam is 360. It means the total question paper is 360 and just 97 marks will be the cutoff for the, you can say, LS portion, and for the GRF at most it can go 110. So it's very easy to clear LS and GRF if you study all the three portions of chemistry equally, like organic, physical and organic. If you give equal weightage to the topics, then very easily you can clear this barrier of LS and GRF. Okay, I have made separate strategy videos also. You may visit, and on the channel you may see that also. Okay, thank you so much. Take care. Bye bye. We will be meeting tomorrow again at 11 a.m. I will be continuing this mass spectrometer from tomorrow. Okay, thank you so much. Take care. Bye bye.